Victor?
You're a liar. That's okay. Good to see you too. I mean, if you're going to go down that route, then let's go. Good to see you with me.
It's good to see you because you're my co-host, and if you weren't here, then I'd have to do this alone. And not like your face is especially beautiful or anything.
I'm pretty sure that I already told you that one of the best experiences in this show was 2 weeks ago when I was replaced by Abby.
Don't say that. I'm attached.
You're saying that Abby is not a good one? It's public.
Play this for
yeah.
The fact that I didn't say that at all is public. Yeah, you're right. Do you play video games?
I do. There's
yeah.
That's the video game. Big
What
television doesn't look that big from this angle.
What game do you like? Or
it needs to have either a dragon or a spaceship in it.
I've been playing Portal a lot, but the reason I bring it up, which is an old game, but I've been replaying it and it's the best. But I was thinking about graphical user interfaces and how you like terminal, like you like text. And I was remembering that when I was a kid, I used to play a game called Zork. Do you know that game?
I know.
Yeah.
That's
yeah.
the text-based adventure, choose your own adventure type of stuff. Yes.
Yeah. And I'd play it with my dad, and he was an accountant, and we had like his accountant ledger for graph paper, and we would like draw maps based on where we were going. Yeah. And I thought maybe that's the source of your love for the terminal.
I don't know, maybe either that or I'm colorblind. I don't know.
But spaceships and dragons are okay. If these GUIs had either a spaceship or a dragon, you wouldn't be hard on them.
Put me one of those and there you go.
All right, let's get down to business. We last week, we poorly named our episode Specialized Templating, but
should have been called Developer Platform Gumbo. Or Gumbo, I don't know how you pronounce it.
Gumbo, you're saying it right.
Gumbo.
I think what those tools were all developer-facing tools that help separate developer logic from operations logic. I think that all the tools last week did that, but also at least one of the tools this week does that too. So we didn't do a great job on many levels. In fact, so Dapr is one of the tools this week. I'm pretty sure Radius, which was on last week, uses Dapr under the hood.
Radius can use Dapr, yes. It's one of the components there.
So today, though, we're not trying to make a parallel between our technologies. Today, we're just going to talk about miscellaneous, as you like to say, gumbo. I like goulash for a soup that has just whatever in it. I think gumbo might be more specific. Gumbo's a Louisiana
sounds better
thing.
Than goulash. Exactly.
Goulash sounds like it could be a shoe or a raincoat.
Yeah.
But it's a suit. What am I thinking of?
Gumbo. It sounds so much better than platform goulash.
So,
I mean, goulash is just the kind of one syllable away from gulag, and that's not the association you want to make.
I don't know what that is, but I kind of think I don't want
Gulag
to.
is the notorious prison-like in Siberia. But if you're ever sent there, nobody's going to see you ever again.
Gotcha. Okay. On that note, let's talk about last week's technologies. There's not really much to say about the system design choice itself.
Yeah.
We talked about WRF. What's WRF?
WRF does many different things. It would be hard for me to even explain it in a sentence or two. It's a kind of collection of stuff. And on top of that, I'm trying to get away from explaining it because I haven't tried it for maybe a year and a half, 2 years, maybe even longer. So I don't know where it is right now, outside of, from the personal experience, let's say, outside of what we were told last week.
It helps deploy to Kubernetes by gluing together commonly used tools, Git and Helm and...
So original Gumbo.
Kubernetes flavored gumbo. Get Helm and Docker. It helps put those together. Radius and Score seemed similar, but Score seemed like a baby version of Radius.
Yeah, Radius, and this is my interpretation for which I'm going to suffer to eternity. Radius is a version of Bicep. Bicep is kind of Microsoft's answer to HCL. And that, at least that's my interpretation. That's how you can manage. HCL is the format behind Terraform, right? Terraform has its own proprietary format, widely used outside of Terraform as well. And Bicep is kind of similar to that, just sufficiently different not to be that. And that's how you can manage infrastructure or services in AWS using Microsoft prescribed format in a way, right? And then Radius is an attempt to bring that to Kubernetes.
Okay. So both of them seem to be like write your application with the Radius or the Score format and then deploy it anywhere. But Radius seemed to be more about all different platforms, and Score seemed to be more about local versus remote.
And Radius has higher emphasis, and I might be wrong, but higher emphasis on enabling one person or one team to define what the other team does, right? So it's closer to internal developer platform logic, kind of, hey, you have platform engineers who are defining this is how your applications should, this is what your applications or database or whatever should do. And this is the interface you can use to do that, right? So it's some kind of
collaboration tool.
Both are abstractions, with Radius being slightly more focused on how others can create those abstractions for you, right?
Okay. Yeah, that makes sense. And then Pipe CD.
Pipe CD, I still don't know what it is.
He actually, Khan, during his presentation, said what Argo CD and Argo workflows is to Kubernetes, Pipe CD is to any target platform. And that helped me wrap my head around it.
Yes and no.
Okay.
That depends. I would redefine it in the light of where we are right now. Is that so? You can look at Kubernetes in two ways, right? One way is that Kubernetes is the final destination, right? That's where you run your applications, essentially, right?
Yeah.
Containers, maybe Wasm. And if that's the explanation you have with Kubernetes, then yeah, Pipe CD is special in terms that the destination doesn't have to be Kubernetes, or even where Pipe CD runs doesn't have to be Kubernetes. Another explanation is that Kubernetes is used to assemble resources that do something, and that something can be inside of that same cluster. It can be in a different cluster. It can be something that has nothing to do with Kubernetes. So Kubernetes becomes that gateway in a way, right?
Kubernetes is a manager, not a destination.
Yes.
Yeah.
And in that case, I could argue that, Argo CD also manages stuff that is ultimately not in Kubernetes, right?
Yeah.
Depends how you look at it. I'm pretty good at thinking this episode, giving explanations that don't mean anything. But we can keep going.
I think Pipe CD was trying to have more to do with like the whole life cycle and day two operations too, maybe than Argo.
There's more than just synchronization. But still, they were very clear that they focus on the latter part of the SDLC. Kind of, you're not using it to build images. At least that's my understanding.
That's my understanding too, yes. And then the final one that last week was Porter.
Porter is some kind of, this is my interpretation of it, a way to create scripts that do things, predominantly install, uninstall, delete, and package all that in a container so that it's highly portable, right? So basically you install Porter and then you download some, I'm not sure how they call it. I'm going to call it recipe.
Okay.
Mixin is a component in that.
Okay.
So you can have different mixins in your definitions, like, hey, I want to execute this, just execute this. I want to run this as another container, and so on and so forth. But anyways, you define what are the
sources.
What should be done when somebody says, "Oh, I want to install X with Porter, whatever X is," and I'm not referring to Twitter now, and I want to uninstall it, or I want to delete it. Or sorry, not uninstall, upgrade. So install, upgrade, delete, and then somebody defines what will happen, and that's basically doing scripting but packaged in a container.
And when like the output of one thing can be the input of another thing, and then that's all packaged together. So you could like hand your application over to a customer or a colleague, and they would just have to install it, and it would do all the installation itself without following a guide or having to understand the application in any sort of deep way. Yes.
Exactly.
Yeah. So, and again, these are not mutually exclusive, nor are the ones today. So sometimes,
the only two that I think are kind of competing in certain way, that would be maybe Radius and Score, right? They are in a similar area. The others are kind of completely separate from each other.
But there was a really nice moment last week when the question was like what tool would like on the screen right now, what would you work well with? And the Radius and Score people, they like chose each other and said like, oh, we'll get together after this and see if we can collaborate.
Oh, exactly. It makes you wonder, why don't we do this in a studio so that people can hold hands?
And then there was just a little kiss. No, freaking amazing. I did think it was really nice. So which one did the people vote for?
Porter won.
Porter.
For a while it was Porter, Worth, same, and then Porter. Porter won.
Porter pulled ahead. All right, let's see it.
No, we will not see it because I didn't prepare the demo.
Ah.
I didn't prepare it for a couple of reasons. First, because KubeCon is around the corner and I'm out of my wits with the things I need to do.
Yeah.
And second, I will do it, but I need to. I want to do it well at one moment, without me saying when. I want to figure out how actually Porter can wrap everything else we did in a way before we reached Porter, which probably should put Porter at the beginning of the whole story of IDP, right? Because a lot of setups were done and a lot of things were executed that could be done with Porter. I just need to figure out how to do it.
So
it will be done one day. One day.
Maybe. Oh yeah. Maybe our next episode's 2 weeks from now. Maybe in time for the recap.
We'll see.
We'll
no
see.
Promises. 2 weeks from now or week before KubeCon. So it depends how you say.
Touche. And that brings us to today's episode, which is the official Miscellaneous episode, which I personally love the Miscellaneous episode.
Gumbo 2.
Gumbo 2. And I just think it's fun to see the edges of things. Like, what are people up to that doesn't quite fit in? And what the bleeding edge.
I'm familiar kind of with two of those three.
The three being Dapr, KusionStack, and OpenFeature.
Yes. And actually with three of the three. Except that one of the three, I'm familiar only with one of those from the stack, right? So KusionStack is a bunch of different things, related or unrelated. And I'm familiar mostly with Carpor, which I doubt we will hear about today. And OpenFeature and Dapr are very, very different from everything we spoke about, right? Because while all the tools are kind of how can we do operations in a certain way, right? Those are more developer-centric, right? I would assume from everything we talk in this chapter, Dapr and OpenFeature are something that developers themselves would be probably the most interested in. That's my suspicion.
Exciting. All right.
Yeah.
So let's bring on our guests. Let's introduce our guests. Does that sound good? All right.
Yeah.
Mauricio is coming on first. Here you go. Welcome, Mauricio. Thanks for being here.
Hey, folks. Yes.
Will you
Very happy to
introduce
be here.
yourself? Nice.
Yes, of course. I can introduce myself, of course. My name is Mauricio Salatino. I'm joining from London today. And I'm currently working on the Dapr project for a company called Diagrid. And yeah, I will be more than happy to take on the challenge of explaining Dapr in less than 5 minutes, which is quite complicated to me. But we will see how it goes.
Awesome. Thank you so much. Bye. Jonathan, come on up and introduce yourself, please, friends.
Oh, and there it goes. Yeah, thanks for having me. My name is Jonathan. I'm one of the co-founders at DevCycle. We're a feature flagging vendor and strong supporter of the open standard OpenFeature project that we'll talk about today, and also on the governance board over there at OpenFeature, and help where I can with some contributions as well. So yeah, happy to run through what OpenFeature is and how we can help your project here today.
Awesome. Thank you so much for being here, and we'll see your
Yeah,
presentation here shortly. Thank you. Bye. And then our third guest, Forrest Chen, is in China, and it's like 2:30 in the morning, I think, for him over there, 2 in the morning. So he sent us a
He
video.
chose to sleep instead of coming here. That's unacceptable.
So we have a video to play for him for his presentation, but KusionStack is represented too. And on that note, I think it's time for Mauricio to do his 5-minute presentation. Mauricio, if you want to get your presentation on your screen, we'll bring you both up at once. All right, here we go.
Okay, go.
Yes, wait. I have my own timer because I need to see Victor and Whitney looking at me before I do my presentation. So let's do this. So Dapr in less than 5 minutes. My name is Mauricio Salatino. I work for Diagrid. And let's switch slides. Yes. So I work for Dignified, and I wrote a book titled Platform Engineering on Kubernetes, where I cover Dapr alongside with OpenFeature. So I think that it's great to have both projects in this chapter, and let's see why. So Dapr helps you to bring developers and platform teams closer. That's the main premise that I will be discussing, trying to explain how it does that now. So if you go to the Dapr website, you will see this diagram that it's pretty complicated, I would say, because there are like different logos, different layers. But the thing that you need to remember from this diagram is that on top, we have developers. In the bottom, we have cloud providers and infrastructure. And in the middle, we have Dapr. So if you want to summarize how this looks, think about this. Like you have developers building their new shiny AI agents, maybe in Python, maybe in Java, maybe in Node, whatever, right? And then they have Dapr application level APIs that enable developers to access complex infrastructure without the hassle of understanding where that infrastructure is or how that infrastructure works. Infrastructure can be cloud services, databases, message brokers, LLMs, and other things. And Dapr also provides to the platform team the tools to configure and wire up all that complex infrastructure. But in general, when we talk about APIs, we don't talk about that in the platform space. We talk about platform APIs. And platform APIs are different APIs from the ones that I'm describing in Dapr. Platform APIs will enable development teams, for example, to provision new infrastructure that has been configured by the platform team. So if I want to, for example, communicate to agents to communicate asynchronously, I will probably need a message broker. But I don't want to install a message broker, and I need a message broker that is configured to run at scale, right? So I will go through the platform APIs, request, for example, a Kafka cluster, and the platform will provision that for me. If I have 2 agents, then the problem is that, okay, now I need to, as a developer, learn how Kafka works. And that can be very, very complicated, not only because I need to learn how Kafka works and the internals and how to use it effectively, but also how do I connect to it securely and reliably, right? That's the first complication. The second complication is that whatever component you deploy, if it's Kafka, a database, or any other thing, or any kind of cloud service, you will have a version associated to it. And for that, you will need to have some sort of clients in your agents. So in this case, you will have the Kafka clients. And at that point, when you want to communicate every agent with Kafka, then you need to make sure that the versions match. And that actually, if you upgrade Kafka in the platform side, you upgrade all your agents with it. So it gets quite complicated. And it's quite like a real life story where that companies they cannot manage Kafka at scale because maybe they don't have the expertise in house. So they might choose to go to use a managed service like Google PubSub, Amazon SQS, or Azure Events Hub. And at that point, then you will need to throw away your agents because now you need to remove the Kafka client, recreate everything, and re-release everything again. So that's why we go back to Dapr. I've been talking about communicating agents asynchronously. Well, we can do a lot of other things like that, like sending messages across agents, like, for example, storing state, doing complex orchestrations with workflows, consuming secrets and configurations, or like using a distributed log without implementing that inside your applications. So how it looks when you're using Dapr, it looks like this. Your agents will be interacting with the Dapr APIs. And as a developer, that's the only thing that you need to know. What are the Dapr APIs that are available so I can use them? And I will build my agents logic with that. If you think about programming languages, again, Dapr provides SDKs in all the major programming languages. So this is how it looks to submit a message, like publish a message using the .NET SDK. That's Java, pretty much the same publish event. That's JavaScript. I don't know why would you be using JavaScript, but if you're using JavaScript, you can do that. And then, of course, if you're building agents, probably Python is your language of choice, so you can do that with Python. For the platform side of things, which I believe it's most of this audience, what you will get is Kubernetes native tools to wire all this infrastructure together so developers can access it. And, it's YAML for sure. So how does it look? It looks something like this. You have a YAML, in this case, a component type PubSub that you can configure to connect to Kafka, or you can configure it to connect to GCP PubSub in this case without changing how the application code looks like. Finally, I wanted to sum it up saying that Dapr provides application-level APIs to solve common distributed application challenges, and it also provides Kubernetes native configuration mechanisms that integrate easily with Kubernetes-based platforms. We just released Dapr 1.15 that includes Dapr workflows and the new conversation API that allows you to interact with the wide range of LLMs. And keep an eye on the news because there is an announcement coming soon about Dapr agents as well. Thank you so much. With 3 seconds on the clock, Toasty again. See you later.
Bye, Mauricio. Thank you.
He's prepared
All right.
too well.
He stole the wind right out of your sails. Yeah. But Dapr's cool. So, all right. So with that, we're bringing on Jonathan. Come on up, please. And here we go. Victor will start the time. Yeah.
Yeah, go for it.
Thank you. That was a tough one to follow. So, OpenFeature. OpenFeature is an open standard that provides a vendor agnostic API for feature flagging that works across sort of multiple feature flagging platforms and tools. And if you've heard of OpenTelemetry, it's kind of a similar style platform to that. For those who don't know what a feature flag is, it's a pretty common software development concept that allows you to enable and disable features within your code without modifying the source code or deploying new code. So basically, most of the time, you're using feature flags to change how your code is actually functioning at runtime and making runtime changes to your application based off user data and things like that. And one of the big things for OpenFeature is for a lot of large projects out there, like you could have thousands of flags strewn throughout your code, right? And there's a real case for a lot of teams out there with vendor lock-in where it's very difficult to safely swap out that feature flagging platform that you might have chosen very early on when it's literally configuring thousands of different parts of your application. And so OpenFeature is very important to allow you to sort of take back some of that control and test out multiple different vendors and potentially combine them together into a solution that works better for your company. It's pretty simple to implement. You sort of set a provider there at the top. You grab your OpenFeature client, and then you can start evaluating feature flags. This is a simple Boolean feature flag, but you can also do numbers, strings, object types pretty easily through the interface. The project's really grown a lot over the last couple of years. There's over 20 plus open source projects and SaaS platforms that support OpenFeature. There's now over 115 providers across the different vendors and open source projects and languages. And it's pretty easy to create your own provider for your own use case. Also I think we support 15 different languages and frameworks now, so most of the major ones that you might be using. Yeah, so a couple of the key concepts of how OpenFeature works. Talked about providers. So providers are actually what's responsible for actually performing the flag evaluations. So, for example, at DevCycle, we might provide a provider for React, and our React SDK is actually what's determining sort of like whether that flag is on or off for that user's context data, and it's kind of the underlying abstraction. And they're very simple. They can be as simple as maybe 40 lines of code to implement. They can come from data just from like an environment variable or flag or a file you might have, or they can obviously hook into an open source feature flagging system or a commercial vendor. Yeah, the evaluation context is kind of like the main container for the data that you're evaluating against, and can be kind of any arbitrary contextual data. In certain contexts, like on the client side, that might be user data or like project or organization data for your application. On the server side, it might be things like server information or like what pod type this is or what service is running, things like that. And that data is then used by the underlying provider to actually evaluate whether this flag should be on or off, or what value it should be served. So yeah, the context data is pretty important, and what sort of drives the underlying value that gets generated. Another powerful mechanism that OpenFeature enables is hooks, and it's kind of a mechanism for allowing arbitrary behavior at different points in the evaluation lifecycle of a flag. So if you want to evaluate like before or after a flag is evaluated, hooks are kind of a way to do that. And they're commonly used for things like logging, telemetry, tracking, validating that like different providers are working correctly, things like that. Yeah, and then finally, the most recent thing that we've added, and we're pushing out, is sort of tracking support, which allows you to measure the outcomes of your feature flags, and sort of conduct robust experimentation with feature flags. So this is commonly used for A/B testing, also for like observability. So if you want to observe the performance of enabling or disabling a flag, tracking can help with that, and also like tying feature flag changes to product analytics. So check us out at openfeature.dev and come meet me at KubeCon at our booth.
Awesome. Thank you.
Brilliant.
That's great. We're going to say goodbye for now and go to our KusionStack. Thank you.
Yeah.
No gong today. You
no
don't
gong.
get to, yeah.
KusionStack is going to be over 5 minutes, but since there will be nobody to answer questions, kind of like I'll let it slide.
Yeah, they didn't get to do an introduction.
Hi, fellas. My name is Forrest Chen. I'm a maintainer for the KusionStack project. I wish I could join the live show today, but I couldn't because I'm probably sleepy in the moment. It's past 2:30 a.m. in China. So what I'm going to do today is do a quick intro into KusionStack and see what it is, showcase some of the cool stuff in it. First of all, what it is, right? We are defining it as a platform engineering tech stack, or in other words, building blocks, right? It's not a platform. It's several loosely coupled components that you can use to build a platform from. We do this because we believe in most cases infrastructure like an IDP are always subject to some degree of customization. Everyone, every team, every company is going to have some opinionated organizational needs that is different. So we're going for a modular approach where you can pick and choose what you need when building a platform. So we have a few products available today, but I won't go into details for each one of them. So, we have Cushion, which is a typical platform orchestrator. You all know what that is. It kind of translates developers' intents, mix them up with platform defaults, and it converts them into actual resources and does state management and all that. You all know that stuff if you've seen previous episodes on tools like Kuvela, Radius, Cratix. So we're not going to dive into that. The part I want to show today is actually a cool little side project on observability. So in very short words, it let you manage multiple clusters at scale, which is a fairly common situation today. It grabs resources metadata from all the clusters in real time and let you do search and insights on them, no matter where they are, right? So architecturally, so let's take a look at this project called Carper. So architecturally speaking, we've got a dashboard that's presenting all that information, and then there's an aggregated API server that sort of stores and manages a few custom resource types, and then there's a syncer, a component that watches the member clusters, and then in real time synchronizes these resource metadata back into a centralized storage. Where, if you want to define some procedures to transform the data, say like mask certain sensitive data in the resource spec, you can do that in the annotations and the labels. We're using Elasticsearch as the default storage backend, but that's designed to be fully swappable. So once you have these data, you can extract quite a lot of insights from them, which I'm going to show you in a demo. So we actually do have a covered demo here that we've deployed in Ali Cloud with some fake data, of course. Okay, so jumping in here, you're going to see a screen that lets you do search, and you can write SQL-like search query. Right, so here, what I'm going to do is I can find, all the resources with the name press in it, in its name, right? So I'm going to hit enter. And here, say, like, this is all the things that has the word press in it, right? So let's go into one of the namespaces here. On the namespace level, you can see a health score. You can see some metadata. There are 13 pods. You can see this is the auditing results from a tool called KubeAudit, which exposes auditing problems that it sees by doing static scans on resources in this namespace or in this cluster, depends on what your scope is. And then you can see, these resources in the namespace are related to some extent, and a list of all of the resources in it. So if we click into a pod, for example, right, you can also see resource level details. This is a pod that belongs to a particular node, and this is a resource this is a pod that belongs to a replica set that belongs to a deployment. You can see the specific YAMLs. You can see the data certain data being transformed. You can see events if there are any, and then you can see logs in case of this pod. And I'm not quite sure why it's not showing. So now, going back to topology here, you can always jump to another related resources from here. And here we're at deployment, of course. And then we can see this deployment is related to a bunch of pods. So, right, and aside from that, and this particular issues here, for example, if you're having trouble, understanding what that is, there's also a tiny little button here that kind of explains what this is by integrating with Kubernetes GPT. And this might take slightly longer. All right, here it is. So it's trying to explain to you what this issue is and what you can do to remediate it. Yeah, and I mean, I think that's pretty much all the resource level insights. And then you can look at cluster level insights. Here, say I'm going to go into this particular cluster. You can see cluster level metadata. You can see an aggregated report on all the issues for all the resources inside this particular cluster. And again, like what we previously seen in the namespace screen, you can see all the resources that is inside this particular cluster as well. So I think that's it, and we're probably up for our 5 minutes window. So I'm going to stop here, and if there are any questions, interests, feel free to drop by our Slack channel. Hope to see you there. And have a good week. See ya.
That was nice. I enjoy that. Like it kind of messed up a little bit. He's like, it's a recorded demo that wasn't 100% there. I think you're muted, Victor.
Look at me. Yeah, it was recorded, but it was live recorded, unedited. So it's cool. It's cool. I like it.
Yeah.
And Especially, I was wondering. I haven't seen the video before the show, and I was since what's the name? Stack something. KusionStack
KusionStack, yeah.
is a collection of a bunch of tools, right? So I was wondering whether he will show all of them or focus on one and which one it will be. And it happened to be Carpor, which is the one I have high opinion about.
That's great. So since you know it well, if there are any Carpor questions or KusionStack, Carpor questions, you can be the one to answer those.
Yeah. So if there are questions about Carpor, definitely. If there are questions about the rest of the KusionStack, I might not be the person. We'll see.
Right on. So I'm going to bring on the rest of our guests, and we'll get started on these questions. So thank you, friends, for your presentations. Appreciate you. And we have a lot to discuss today, which awesome, y'all. Way to ask so many questions. I love it. I guess, do you want to get to the first one, Victor, which is for you? Why doesn't Crossplane have an official UI?
Sure.
Yeah.
Sure. So there are a couple of functions. So officially it's hard to define because it's an open source project, right? It could be inside of Crossplane organization. It could be outside. Now, it is true, we don't have a UI inside managed as a project inside Crossplane organization, but there are a couple of UIs outside. There is also, I forgot the name. Mauricio, do you remember the name?
Comoplane.
Comoplane, yes, Comoplane. Yep. There we go. Comoplane is one of them. And I'm especially excited about plugins for Backstage that Scott is working on. They're absolutely awesome, right?
Cool.
And then there is unofficial commercial version Upbound. If you want to give us money, that's go for it.
Right on.
That's as much sales as I can do.
It goes straight to your wallet, right?
Straight, exactly. Yeah, I get 90% of the sales. Yes.
Perfect. That's right.
Exactly. That's why I live in such luxury.
I'm buying. Take my money.
Talking about OpenFeature. OpenFeature is great for devs and for POs, which I assume is platform operators. Devs can do continuous delivery, and POs can decide what features are made available when and to whom. How can you tell me how does OpenFeature or feature flagging in general relate to progressive delivery?
It doesn't.
Yeah, it
doesn't.
Well,
No?
it can. Like there is a Kubernetes provider and things like that, and so you can combine OpenFeature and Kubernetes and things like that together. I would say most people use it more for, like, we use it internally for continuous deployment, right? Where like we're deploying everything we build and immediately to production, keeping it behind feature flags and doing things like testing in production and things like that. And so, like, that's really the power of feature flags, is when you can really sort of like, allows you to move a bit faster than that and do things like testing in production and do QA and do beta releases and stuff like that at a runtime level, where you're saying, I want this user to have access to this, not just like, I'm going to deploy this version of the code that might have this feature enabled.
So it's more of a granular control with OpenFeature, with feature flagging.
I was kind of hasty when I said no immediately to progressive delivery, but now when I think about it, if you look at it, and correct me if I'm wrong, Jonathan, if you look at it from the functional level, both progressive delivery and feature flagging allow you to select a subset of your users, be it a percentage or a region or something, who will see it, evaluate the results, and then choose to proceed with it, right? Kind of increase the reach, at least in theory, right?
Yeah, but most progressive delivery are like, you're just maybe doing straight randomized percentages, right? Like, you're saying like 5% of my users, I want to have this new version of the thing, right? Where with feature flagging, you can do that more at runtime, or I can say, I want people in Toronto that are maybe not part of my like these organizations to have access to this feature, right? You can do much more granular control, or you can say, hey, I have a beta test group of beta test users. Like, I want those customers, those individual people to have access to, and you can implement that both on the client side, so on your React application, and on your backend in your API, sort of at runtime. And so you can do those straight, like just rollout percentages as well, but it gets more interesting when you get into sort of more of the runtime control and do things a bit more challenging than that.
Right on. And Mauricio, how does Dapr play into this story where platform operators decide what features are made available?
I think that's a little bit different, but something that I wanted to say is that there is a strong relationship between OpenFeature and Dapr, because they are actually solving different problems, but in a very similar way.
Yeah.
Right? Like, they are both providing tools for developers to use. And that's kind of like, if you go deeper, you will see that OpenFeature gives you SDKs for languages, and Dapr does the same. And they are both interacting with APIs that can be provided by different providers, right? Like, they can be implemented by different providers, giving people the choice of which provider they want to use while keeping their applications the same. And I think that's a very interesting thing, because I think that, Victor, you said it when you opened it. It's like these two tools are a little bit different from all the other tools that you have been discussing here in the channel, right?
And I have a question. Like, sorry, Victor, you
No, go for
finish.
it.
What's the benefit? It seems like with OpenFeature, there's a lot more implementation details are exposed to the developer. And with Dapr, that's all behind an API. Is that true? With all the when Jonathan, you're making a face like that's not true, but Jonathan showed like all the context that was possible, and how does that relate in Dapr?
So I think that Jonathan can explain that, but like what Jonathan showed is like the standard APIs to access feature flags. And the things that I showed, it's basically the same. It's like the standard way of publishing messages in different languages. Right.
Okay.
So I think that's kind of like why they compare like one-to-one. It's pretty much the same approach. It's like they are abstracting away how feature flags are implemented. We are abstracting away different APIs that do different things, but using kind of like the same approach.
Yeah, it sounds pretty similar. Where you're trying to create that open standard abstraction layer right on top of these things, so you can that abstraction layer then obviously enables a lot of things where you can easily switch between providers. You can sort of combine multiple things together. You can sort of test the performance of different things. Like, having that layer allows you to do things that that otherwise you wouldn't be able to do.
And it's one thing that I wanted to mention about like having this like standardized interface is that sometimes when people hear about these things, they think about, oh, but you're using the least common denominator here, so you're losing a lot of features because you are now using a higher level abstraction. And actually, that's kind of like what I try to explain. I think that Jonathan, you did the same. Is that behind the APIs, you are enabled to configure like the provider specifically with the features that you want. So operators, like people from platform teams, they can actually fine-tune how to consume, the different providers in a way that provider specifically does this very specific thing that I want to use, right? So developers access like a generic interface, but at the same time, platform engineers are in charge of configuring that, tuning that in the backend, so it works, for that team.
Cool. Did you want to say, Victor, I cut you off earlier. Did you have something you wanted to say?
No, nothing special.
Okay.
I'm going to throw something outrageous here, but now
Love
that
it.
both of you are explaining how that work, it actually reminds me of crossplane as well, right? In terms that somebody is in charge, in case of your tools, kind of like configuring the providers and what they do. There are no limits really there. So limits are more, not limit, but abstractions are, limits are created within a company in form of abstractions that users at the end use, right? Kind of how you don't need to understand the specific implementation of the OpenFeature tool that is running behind the scenes. You have this interface, go for it. But on a provider level, I'm still in control of the choices that I can make, right? And similar thing with Dapr, right?
Yeah. And I think that that's extremely important for the new kind of development that we are doing today, that it's extremely complex, consuming a lot of cloud resources. when you think about having an interface that basically abstract away the complexity of all that infrastructure, then you start opening the door for like more local development experiences. Both with Dapr and with Feature Flag, you can actually run applications locally with like a local feature provider, and with Dapr with local API implementations, without the need of connecting to something that it's only running on Google or on Amazon, right? So you can build your applications, code everything, test everything, and then when you move to production, you use the same application code base, but it's configured differently to access the real cloud resources.
So here's a question. This is now for you, Mauricio. Just popped up into my head. Can you use Dapr for mocking?
Can you use
You know,
Dapr
so let's say that I'm connected in production to a database using Dapr, but when I work locally, I would like to skip the mess of having a real database in a way, right?
Yeah. So you can do that. There are a couple of options, but nowadays, again, you can start up a database with a container, right? So you can actually connect the local instance to a container, and it will work.
That's true. And database, unless it's Oracle.
No, do not do that.
Crossplane has a dependency on Kubernetes. Yeah, does Dapr and OpenFeature need Kubernetes? No.
That's a very good question. Go, Jonathan.
Yeah, for OpenFeature, you're generally installing the SDKs like into your application code, right? So it's either installed in your backend API code, or your client and or your client side code, whether it's like your mobile app or website or something.
Yeah, in Dapr, it's like you can run it on Kubernetes. It's a Kubernetes extension, but you can also run it outside. So if you have like VM-based workloads or like on-premises workloads that are running outside, you can actually connect to Dapr and install Dapr outside of Kubernetes. That's a different story, right? Like in the in this channel where we're discussing all things about Kubernetes, I would say that it's a Kubernetes extension.
Right on. To answer this question, Dapr is a tool that's in the CNCF. Dapr is an acronym, yes? What does it stand for?
It stands for Distributed Application Runtime, and yes, it's a CNCF graduated project. That means that it went through a long journey of maturing until it's being used by a lot of companies.
That's a big deal. That's awesome. Congratulations.
I will add there that OpenFeature is in CNCF as well.
Yeah,
Yes.
yeah, we're an incubating project right now, so hoping to get
Right
there.
on. Cool. And then this is a question for both of you, really. Did you just move lock-in to your particular tool instead of escaping vendor lock-in altogether? If I use Dapr, am I locked into using Dapr? If I use OpenFeature, am I locked in? Jonathan, okay.
Let's start with Jonathan. Yeah, go for it.
Yeah. No, like like the point of an open standard is that you can sort of re-implement providers for your own internal services, right? So like the whole point of OpenFeature is to allow you to easily port between different providers and things like that. And one of the things actually as a dev cycle we've been working on the last year or so is the ability to run multiple providers within OpenFeature at once. So you can easily sort of like actually run a migration. Say you're using an open source platform and you want to actually migrate to like a SaaS provider like ourselves. You can actually run that migration using the multi-provider that we open sourced for OpenFeature, and actually like slowly migrate your flags from kind of one provider to the next and do things like that, right? And that sort of abstraction that OpenFeature provides allows for you to easily sort of make that switch a lot less painfully than it would be to just like rip and replace throughout your code base.
Yeah, yes to all of that. I think that's the thing. It's like open standard. It's like an open source project that you can choose to use, and it will follow those kind of like standards defined there in the APIs. And then you can implement whatever provider you want. I would say that it's like OpenTelemetry, another similar kind of thing in a way, right? Like if you're using OpenTelemetry, well, you're kind of like tied to that. If you want to change OpenTelemetry after you're using it, good luck.
You can fork it if you like, but it's up to you.
Yeah.
One thing I would say is that you're always locked into something, just to be clear.
Yeah.
If you use Kubernetes, you're locked into Kubernetes, right? If you use whatever you use, you're locked into it to some level of another, right? You might need 5 minutes or 5 days or 5 years to get out of that something. Use PostgreSQL, you're locked into Postgres, right?
Uh-huh.
Now, the question to me is not really whether you're locked, but what you're locked with. right?
Is it a big
it's better
project?
to
Is
be-
it community supported? Is it an open
Exactly.
standard? Yeah.
Exactly. It's potentially better to be locked into CNCF project like Kubernetes that has infinite number of distributions than to be locked into Lambda, right? Because that's proprietary, right? This is in a foundation, or it is open source, or it is proprietary, commercial. It's more about what you're locked into. And then on top of that, things like OpenTelemetry and OpenFeature, and I'm not sure about Dapr. Mauricio will need to correct me, right? Kind of they are layers in between what you and what you're locked with in, right? So OpenTelemetry allows you, I'm just using a different example, to say, hey, I don't want to be locked into Grafana, Prometheus. I want to be able to switch from that one to another one more easily.
Yeah. The difference with Dapr is that the Dapr APIs are defined by the Dapr project. And again, I think that, and that's only the reason why it's only defined in there is because there is no other place to put these APIs. But if you look into, for example, some WASM initiatives, like these communities that are trying to create like entire platforms to make the developers' life easier, they are creating similar abstractions. So there have been a lot of conversations about, okay, maybe these APIs needs to go to like a standardization body, because actually the behavior, it's not Dapr specific, and the implementation is across multiple providers, right? So we already have like implementations for all the major cloud providers and for a lot of on-prem kind of like components. So it kind of makes sense to say, well, this actually is like a standard behavior that can be externalized to be consumed and to be implemented by other providers too.
Cool. What's Unleash? Is it similar to OpenFeature?
Yeah, Unleash is like an open source feature flagging like operator that you can run yourself. So you can hook up Unleash into OpenFeature, and it can be like the provider source that actually makes the decisions about your feature flags. So yeah, it's one of the open source sort of options you can use and plug into OpenFeature.
And does OpenFeature offer a default implementation?
Yeah, I wouldn't say there's like, so there isn't specifically a default, but there is an open source project called FlagD, which is associated with OpenFeature, which it's like a very basic sort of flagging operator that you can sort of define your flags in sort of a file, and it'll sort of run at sort of high, like it's got pretty good performance at sort of just serving flag values to your OpenFeature SDK. So yeah, so FlagD is kind of like, I would say the simple to use sort of OpenFeature supported operator for serving those values. And then you can, like, the reality is I think most people come to OpenFeature with like, oh, I'd like to use one of these vendors or one of these open source projects that I already know, like Unleash or Flagsmith or DevCycle or LaunchDarkly or something like that. But I'd like to use OpenFeature as kind of the interface to those vendors, so that yeah, I have the ability to switch more easily and things like that.
Cool. And then we talked about how your two projects are kind of similar, and I guess Crossplane too. Can you say, like, when is a use case where Dapr is a good choice? What's a use case when OpenFeature is the better choice? Maybe Crossplane too.
No, they're very different.
Yeah. Well, we'll leave Crossplane out of it.
So I think that's kind of like the reason why, like, I covered in the book in the same chapter both tools, because they can be used together for enabling developers to have some sort of, like, the title of the chapter is platform capabilities. Feature flags, like offering, developers feature flagging options, will give them the freedom just to do more coding and just to release more often. And Dapr will simplify their architecture by solving some common distributed application challenges. So I think that they're just tools that they can use, and it really depends on the maturity of the team if they need tools like this or not.
Yeah, I'd agree. They're sort of tools that can be used in parallel and for different use cases, right? Where feature flagging is probably more commonly used on the front end and sort of by application developers, where probably Dapr is more used by infrastructure devs and things like that. So
that's helpful. Thank you. Victor, this is a carpool one. It's for you.
Okay. So
well, it's It looks
the
like
part,
yeah.
Go for it.
You go.
Yeah, so the part of the presentation where you saw the boxes, how they're connected with each other and so on and so forth, right? That's similar from the UI perspective to Argo CD. And that's where any similarity stops, right? They're as different as it can be. Argo CD is a way how to synchronize the state, the desired state stored in Git into your Kubernetes cluster. That's what it does. Kind of basically, it's kubectl. I'm going to simplify it greatly, but that's kubectl run. Pull git or clone git kubectl, and repeat that all the time. It's much more complicated than that, but it's basically continuous synchronization. Carpor solves a very different problem, and that problem is how can I see and more importantly search across multiple clusters, right? Because if you go the traditional dashboard route, you would have a dashboard and you say, go to this cluster, and then dashboard goes to that cluster, sends a request to API and gets something back, right? Which is very limited. Kubernetes API is very limiting in terms of what you can do, right? You cannot say, oh, give me all the resources where word Victor is mentioned. You cannot do search, right? Mm-hmm. What Carpor does is that it loads essentially information from etcd from all the clusters into a central database that is a SQL database, or it's not a SQL database, it's Elasticsearch, but it's a database that and allows you to search anything anywhere, right? And that's very different from, hey, let me see what's happening in this specific cluster.
So we covered as part of Kubernetes dashboards, we covered Headlamp and Kubernetes dashboard. It was literally called Kubernetes dashboard, but those are only for. This should have been there.
Yes.
And it's only one. This one does multi-cluster plus intelligence.
Yeah.
When the others are single cluster.
I was kind of disappointed with presentation, not in a negative sense, or actually in a negative sense. That I think that
that's what happens when you're not here in person. Victor will talk trash about you.
There we go.
Yeah.
I can trash talk your project. Actually, it's a great project. I think he only brushed through the search. Search is the main feature. Basically, you can give me all the resources where anything failed, right? Give me across all my clusters. I don't care which resource kinds you have. I don't care which resources you have. It's all in a database, and I can search it and get instant results. And then later on, I think that this is very early now for Carpor, but it has a huge potential with AI. Unlike other tools, simply because if all the information from all the clusters is in one place, then you can start asking intelligent questions, right?
Yeah.
Any other solution that doesn't have a central database would say, oh, you want me to say what's wrong in one of your 200 clusters? Well, go watch something on Netflix, and when I finish querying all that stuff, I'll give you the answer, right?
Right on. So then, real quick, how does Backstage relate to Carpor?
To Carpor, no, I don't think. It's closer to compare maybe with traditional dashboards and Backstage, right? It's closer to
I think that like Carpor, they also have like a Backstage plugin, so probably they are complementary. Like you can integrate everything together.
Yeah. But Backstage is not Kubernetes only. It's basically about cataloging everything happening anywhere. It's a catalog. This is a real-time information about anything happening in your cluster, which is kind of different.
Yep.
Jonathan, this is a statement, not a question, but I'd like to hear your thoughts. This person thinks releasing features should be a business decision, not be behind a technical hurdle.
Yeah, that's definitely one of the things that feature flags enables, right? So like you can change who has access within the various feature flagging platforms to actually click the button to release the feature, right? So the engineers can wrap their changes in a feature flag and go and test it in production within their team and with their QA team and whatever. And then the the business team or the product team or whoever within your organization can then go through an approvals process to like approve the feature release. So like in our platform and dev cycle, we literally have an approval system that you can use to like to go say, hey, I need approval from whoever and within the business to release this feature to everybody. So yeah, that's one of the things that feature flags enable.
Cool.
The important part, and correct me, Jonathan, is that when you choose to release something by enabling that something as a feature flag, right? You're not doing the release.
You're not
itself.
shipping code.
Kind of like
the code,
you're not deploying anything.
Yeah, the code's already shipped. You're just turning it on and turning it off.
And here's another question for you, Jonathan. Some of the feature flagging solutions have vendor-specific features. Is there anything you guys are doing to support those?
Yeah, that's a good question. So OpenFeature obviously wants to be a fairly simple interface, right? Like we that is pretty applicable across the wide-ranging vendors and different ways you can instrument a feature flagging SDK, and I think we've done a pretty good job at that. We've added also additional functionality that I talked about, but there were some gaps. So like the biggest gap we kept hearing about was events and tracking events for A/B tests. So that's kind of like what we worked on for the last little bit to get that fully rolled out to all of our SDKs. And we're sort of reaching the point where we're thinking that our spec is getting close to being pretty locked in, and that we don't need to expand it too much more. But there are a couple of things like being able to get a list of like all feature flags and all their variables that certain vendors have and are useful for certain use cases that we've been discussing to add in. But most of the time, when you're setting up a provider, you can still get access to the underlying like LaunchDarkly or DevCycle or whatever SDK that's attached to that provider if necessary, right? So if you need to say there's one method on the LaunchDarkly SDK that you need access to, you can do that. Also, all the configuration options for the LaunchDarkly SDK are usually exposed through the provider as well. So you still have access to like configure those sort of underlying SDKs as needed.
Cool. This is the last one for Dapr and OpenFeature, the last question. Did the devs have to configure the API adapters for each stage? Let's start with you, Mauricio.
No, that's the whole point, right? Like the people configuring kind of like the real components, the implementations for the things behind the APIs are the ops teams, right? Mm-hmm. So the ops teams will configure all the things. And yes, like Dapr and I think an OpenFeature as well, they provide that kind of like service interface that you connect to, and then you just use that API. And then the implementation is configured behind the covers, but by the platform team or the operations team. Yeah.
Anything you'd like to add, Jonathan?
No, I think Mauricio covered that one.
Cool. And then Victor, one last one for Carpool. Is it eventually consistent with the cluster?
Yes. So you get near real-time information, right? I'm saying near because, depending on how much resources you put into the database that is running behind it and so on and so forth, it might take a millisecond, it might take a second, it might take minutes if you have, Google size. But yeah, it is eventually near real-time consistent with the cluster.
Right on. And so finally, what I want to hear from each of the guests is why we should vote for you. So Mauricio, why should we vote for Dapr?
I think that you should vote for Dapr if you want to enable your development teams with simpler APIs to solve complex distributed application challenges. And if you are like feeling the pain of not knowing for sure which infrastructure are you going to be using later on in your project.
Amazing. Thank you so much. Goodbye.
Thank you.
And why should everyone vote for OpenFeature?
Yeah, I think OpenFeature is a powerful interface for teams looking to adopt feature flagging as like a core part of their development workflow. And pretty much any team that's looking to use feature flags should really adopt OpenFeature and get the flexibility of being vendor agnostic and being able to hook into sort of the open source community that we've developed.
Thank you so much for sharing your time and your expertise with us today.
Yeah, thank you for having me.
And Victor, why should people vote for KusionStack or Carpor?
For KusionStack, I don't know, but for Carpor, at least from my perspective, the ability to find anything in any of your clusters using SQL query instead of fighting with silly labels in Kubernetes.
Get rid of silly labels. I'm all for it. So now what's left is for you, the viewer, to go vote right now. We have a poll that's live in the You Choose channel in the CNCF Slack workspace. You can find details to connect to that if you're not already connected in the description of this video. And join us, not next week, but 2 weeks from now, we're going to do the season finale and recap every single IDP related tool we've talked about all season, and do the demo, end-to-end demo of all the technologies that you have chosen. Victor's grinning. That's what we're going to do 2 weeks from now on Tuesday. So join us for that show, please. Anything else you'd like to add, Victor?
No, it's all good. See you in
Awesome.
2 weeks.
Thank you, everyone. Goodbye.